So yes, so now we will be looking at our topic number 1, which one states basics. Now, every one of you must be knowing that square of a number means multiplying the number with itself. Example, if I say find the square of 25, you will be writing it as 25 plus 25, and you will get the answer as 625. Now with this sort of understanding, if any number be given to you, suppose if I give you 1, 2, 3, 4 whole square, you can always multiply this with itself and you can get the square of this number. This will be 1522756. So any number if given to you, you can always multiply it and you can get the answer. And if you have already gone through the multiplication tricks, so this multiplication also you can do very quickly to reach to this answer. So why should we know all the details, whatever we are going to discuss in our subsequent slides, why you should watch this video further. Now, the very first thing what you should understand is that multiplying is not always an option, and you can reach to the correct answer just by eliminating some option. And to eliminate option, you need some extra knowledge which has to be developed here. Extra knowledge is required. Now, this extra knowledge will also help you in solving questions of number system. So, in short, this understanding of squaring a number will form a basis for many other subsequent chapters also, and to watch this is important. Now, what and how we will be developing this extra knowledge will be little tricky, and it is purely observational based. It is not something so wherever the mathematics will be required, I will be showing you. Other than it is purely based on your observational skills, but those observations has to be told to you in advance what I'm trying to do in here. Okay, so first observation what you should see, that whenever you square a number, the last digit of that number has to do with the last digit of initial number. What I mean to say, this was the number, this was the last digit of number, which was 5, and this is the last digit of the square, and these both are related. How? That I will just show you. Suppose you take any number, like suppose if you take, let us start with smaller number. Let's take 72 square. So 72 square, when you will multiply 72 and 72, then you can very well say this is 224, this is 2714. Then you put a cross or 0, and then you will write again 144, 150. So you can always see that this last digit, when you will be adding these two, it will come 4 and some other digits which we are not concerned right now. This is the 4, which is the last digit. So you can see that this last digit is the square of, this is last digit of square of last digit of number. Means this was your number. This last digit of this number is 2, last digit, and square of this last digit is 04. Means so last digit is same. Means last digit of number, its square, and the last digit of that is same as the last digit of square. Okay, this is one observation what we have seen, and you can always take it to next level, or you can check for any sort of number. Any number, if you will take AB, you will be multiplying with AB, you will be getting B square, and then you will put a cross and you will see this is B square. So whatever will be the square, last digit of B square will be the last digit over here. Okay, so this is one understanding what we have developed. Now let us see square of some common numbers. Square of some numbers. So before we write square of some numbers, you should understand that any number now if you will write, so that number has to end with, like this last digit can be either 0 or 1 or 2 or dot till 9. So this last digit can be only one of these 10 numbers. Okay, so you like whenever you will be squaring it up, you will get an output number. So this last number will be last digit of square of these 10 numbers only, as we have just discussed now. So first of all, what we have to do, we have to remember the square of these 10 numbers. Understood? Like any number if you will be writing, or if any number be given to you, whatever that number be at in like arbitrary, you can just think of any numbers. Like suppose if you take 1, 2, 3, 4. So this is the 4, and this 4 is one of the element of the set of 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So whatever you will be getting answer after squaring it, this last digit will be 6, because 4 square is 16. So last digit is 6, and this will be over here. Okay, so what should be our basic aim? First, our aim should be to remember the square of these numbers. Okay, so let us try to write those up. So the numbers will be 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. And when you will be squaring them up, you will get 0, 0, 0, 1, 0, 2, sorry, 0, 4, 0, 9, 1, 6, 2, 5, 36, 49, 64 and 81. Now, whatever sort of number you will be writing, this last digit will be there. Means any number which you will be squaring, it has to end with one of these last numbers, underlying numbers. Example, you take any number 765. So last digit is 5, one of these numbers. When you will be squaring it, so you just see 5. When 5 is squared, it becomes 25. So last digit of this number will surely be 5. I don't know about rest of the numbers, that we will see in later lecture. But yes, right now what we can tell is this 5. Now, the first observation what we should make from watching this, observation number 1. So our observation number 1 is that all these last digits in this, some numbers are missing. And those numbers are 2, 3, 7 and 8. Now, easy way to remember is it 2, 3 and then you remember the tens complement. So it's 3 bar actually and this is 2 bar. So this will be the easy way to remember this. You just remember that the last digit of any number squaring after squaring is not ending with these numbers. Not ending. So what result are we inferring from this is that suppose if you have a number, it will surely have one of the numbers from this set. But if you will squaring it, you will get one answer. But the last digit cannot have any of these 4 numbers. Those numbers cannot be 2 or 3 or 7 or 8. So this is the very first observation what we saw. So how it will help us? Let us see some questions. Okay. So the first question be find the number of perfect square in the given set. And your set is element is 2, second element is 2, 2, third element is 2, 2, 2, 2, 2, so on and so goes till 2, 2, 2 n times. Okay, so this is first element, this is second element, third element, nth element. Then n plus nth element is 3, 3, 3, 3, 3, 3, dot, 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 3, 3, 3, n times. Similarly, 7, 7, 7, 7, 7, 7, dot, 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 7, 7, 7, n times. So now you can see in this particular set, there are many elements. Actually, there are 3 n elements. First element, second element, third element, dot, dot, n elements. Then n elements over here also, n elements over here also. So total 3 n terms are there in this set. And the question is asking how many perfect squares are there in this particular set. Now, in this very well you can see this the last digit is 2. Here also last digit will be 2, 2. And after n times also this will be 2. So this none of these elements can be a perfect square because just now we have seen that a perfect square cannot end with 2 or 3 or 7 or 8. So with this also no perfect square can be there. Here also no perfect square can be there. So the answer of this will be 0. This was the first very elementary question and the application of first observation whatever you have done. Now going to the next little complicated question. Now question is find the solution pair xy satisfying the equation x square minus 5y square is equal to 19762, where x and y are less than equal to 1000 or 10,000. Now you have to solve this question. Now in the very beginning, if you see this question, you will not be able to get how to solve it. Like you can pause this video and you can try it yourself. But I will be proceeding with it. And now how to solve this? If this question be given to me, the very first thing what I will see is that here the last digit is 2. So let us see or try to solve it by last digit. Okay, so we know that any number when it will be multiplied by 5, the last digit of that number will be either 5 or it will be 0. You can take any number, like this y square may end with any number, like it may end with 1, not with 2, not with 3, then 4 or 5 or 6, not 7, not 8, 9 and then 0. And if you multiply any one of this with 5, you can see it will either end with 5, here it will be 5, or it will be ending with 0. Here it will be 5, here it will be 0, here it will be 0, here it will be 5, here it will be 0. So this particular number will end with either 5 or 0. So if I want the last digit as 2, then definitely this x square should end with 7. Then only, suppose if you will have a number as 127 minus 125 or any like 125, I'm just writing it for a while. Suppose any number with 5 and then this last digit will be subtraction and then you will get as 2 because here this 2 is there. So this x square has to end with 7. Then only the subtraction of this will give you 2, or this x square should end with 2. that when 0 is subtracted from it, it will give you 2. But as you know that no of the x square can end with either 7 or 2, so no solution of x is possible. Like whatever x you will be putting, you will never get a 7 at last, or you will never get a 2 at last. So in this question, no such x value is possible. So there will be no such value of y which will be possible, which will give you this answer, and so the answer will be 0. So you can very well see the very first observation what we have done, that any x square cannot end with 2, 3 or 7 or 8 can help us in solving question. Now, the problem with this observation is, observation number 1 was that 2, 3, 7 and 8 are not there in the last digit of x square. Means last digit and x square, this cannot be there. Okay, now with this there is a small problem. What problem is there? I just want to show you that suppose if I write 1 square, this is 0, 1, 2 square, this is 0, 4, 3 square, this is 0, 9, 4 square is 1, 6, 5 square is 25. Okay, now you just see what will be 6 square. 6 square will be 36, 6 square 36, 7 square 49, 8 square 64 and 9 square 81. So if you see this numbers, one very common problem what you can see is that this 6 is also there in 6 square. Like 4 square, last digit which is 6 is common for both 4 and 6, 9 is common for both 3 and 7, 4 is common for 2 and 8, and similarly 1 is common for 1 and 9. So this means that the last digit is not unique. So what should we do, or what problem will it pose to us? Now this right now, this understanding will not create any trouble in squaring a number, but whenever in future when I will be telling you how to find square root of any number which is ending by 1, then you will be trapped with two options, that whether this square root of that number is ending with 1 or that square digit of number ending with 9. So this understanding over here has to be developed just now, that last digit is not always sufficient to get you the required answer. So we have to go to next step, and next step is to let us check the last two digits. Let's check the last two digits. So yes, last two digits are not repeating. Like last two digits of 0 are 0, 0. Last two digits of 1 is 0, 1, 0, 4, 0, 9, 16, 81, 64, 49, 36 and 25. And we can see they are not repeating. So what, like, is that sufficient? Means next question what you should ask me, that okay, I will remember the last two digits from 0 to 9, but will that be sufficient, or is there any other sort of pattern which will repeat after 10? Until how many numbers should we remember these square values? So answer to that I will be giving you with a small proof. That proof is also very handy. Suppose any number be given to you. This is a proof for last two digits of square of any number. Now suppose if I give you any number n, can you write this number n as the closest multiple of 50? Like, can you write this n as 50m plus or minus some value x and then whole square? Now why I am writing this, if I try to explain you with this syntax, it might be difficult. So let us take a numeric value and let us see. Suppose I give you a number as 38 and I ask you to square it. Can you write 38 as 50 minus 12 whole square? Yes, we can definitely write this. Now let us expand this. So you know that this is 2500 minus 2 into 50 into 12 plus 12 square. So now this particular term, this simplifies to 2500 minus this is 1200 and this plus 144. So now you can see that this 0 has nothing to do with last two digits, this two digit has nothing to do with the last two digit, and these 244 are coming here. Okay, so this last two digit has to do with the difference from 50. Means this last two digits are square of this 12. Okay, so is it true for all the numbers? Yes, definitely. Even if instead of 38, if I would write 62, so this you could have written as 50 plus 12 whole square, and instead of minus here it will become plus, and you will see this will become plus, and again you will see the same 44 will repeat. So whatever be the number, if you can write it as the closest some number difference from the multiple of 50, you will get the last two digit of the number which is the difference. Means in here what I was trying to explain you, that if any number be given to you, you can write this number as a nearby the multiple of 50, and then there will be some extra delta or x, and the last two digits of this number will be of x square. The last two digits of this number will be of same as that of x square. Okay, so this understanding if you have, then we can see how many values should we remember from this. Okay, first see what are the multiples of 50. Okay, let us take one more example. Like you might be thinking, this is directly 50. Here m is 1. What will happen if m is 2? It will become 100, and we will see something. Suppose your answer is, now our next example is, suppose we are taking a number as 82. So 82 square can be written as 50 into 2, which is 100, and then minus, this is 80. And then you can very well see that this number will again form the same pattern, and at last you will be getting as plus 18 square. Here some numbers will be coming with double zero, here's minus some number will come with double zero, plus 18 square, and 18 square, as you know, it's 324. So last two digits will be 324, which will be there. So whatever will be the number, last two digits will be Pakka 24. This is, I'm very much sure, because this is, I'm able to write it as multiple nearby the multiple of 50. So let us first see how many squares are needed for us to remember. Okay, so let us first write the multiples of 50. So on the number line, if this is 0, this is 50, and this is 100. So you see which will be easier. So instead of remembering the square values from 1 to 50, what we can do, you can make a partition over here. Let that center line be 25. So somehow, if we remember the number from 0 to 24 here or 25 here, I can write the same on the number side here as 50 minus these numbers. Here it will be 75. So on this we will write as 50 plus x. Here I will be writing 100 minus x. So if this is the x, like if x belongs to this range, you can see very well that by hearting this many numbers can be repeated for this by writing 50 minus x. For this range we can write as 50 plus x, and for this range we can write 100 minus x. Then after this also, suppose if you need to go, this is 200, this is 150. So you can go 100 till here, till 125. This will be x. So whatever be the range, you can always write some multiple 50 like some multiple of 50 plus or minus this x, and you can do the square, and you can always say that the number has to end with the same two digits of x square. Okay, this is the first understanding what we have to develop. Now once this understanding has been developed, our next step will be to by heart squares till 25. By heart square of numbers till 25. So let us start doing that. Okay, so I hope like here is 76, here is 76. So this we don't need to remember. 27 square, this is 29, here is 29. So before 25, there will be no repetition, and after 25, we will be seeing the repetition of these numbers, because this 26 can be written as 50 minus 14, 15 minus 24, and you know that 24 end digit is 76, so here also you can see the same 26. Like similarly, 29 can be written as 50 minus 21, and this last two digits of 21 square is 41. You can see here the 41 is there. Okay, so you can very well see the pattern. Now you have to remember these values, and when I say remember till 20, like 25 is also most of us be knowing, and there is a special trick for this also which we will be discussing, so forget 25. So till 24 you should by heart these squares, and you should remember two things. First, the square of the number, and second, you should have a perfect recall that whenever you see a number, suppose ending with 84, then you should first strike the first thing what should strike you, that as this is 84, and in the range of 1 to 24, only 22 is ending with the number 84. So this square root of this number has to surely do something with multiple of 50 plus minus 22. This should be the first thing which should come in your mind. So there has to be two things what you have to remember. First is the number of squares till 24, and second, that the last two digits of all numbers should have a perfect recall. The moment you see 41, you should be very much happy that this number has to do something with 21. Okay, so this what you have to be very much thorough with. Now see, based on this understanding, how questions are framed and how you can solve it very neatly. So this question what I am going to discuss right now, this was asked in CAT, and it troubled a lot many of students because they were not having the understanding of this. And the question is, a number, a perfect square of 4 digit is having a form of xx yy, where x is not equal to y. Find the value of root xy, root xxyy. Find the value of, first this was one, and second question was, find the number of solution if the number is of the form XYZZ. Okay, so the question is very simple, that there is a perfect square of, actually this was asked in the CAT, and I am just asking you, putting this additional question to, like, just to tell you how this question could have been furthermore complicated. So let me explain you the question first. The question says that there is a 4-digit number which is of the form XXYY. Means, suppose if you are writing a number as 7244, so it means that 44 is same, but these two numbers also has to be same. So this number is something like 1122. Okay, I mean these two numbers are same and these two numbers are same, and it is saying it is first for a perfect square, then it is 4-digit, and this is the form for this, and they are asking you the square root of this number. So how to approach this question first? Now, the very first thing what you should have seen in this is, you can give it a try yourself and you can see whether you can solve it or not. Then you can see the way I tried to solve it. Okay, so the very first thing what I will see, it's a 4-digit number, 4-digit perfect square. So what I will be seeing, that what is the first number whose square will be a 4-digit number. Okay, so I know that 30 square is 900. Okay, 31 square you can check. Now yes, one more thing I want to tell you right now, that how to find square, like sometime what will happen, you will forget how to find square root of 31. Okay, there will be many tricks what I will be telling you in further topics, but sometimes it is quicker if you do multiplication of this as 31 cross 31, and if you have seen my multiplication like video, if not, kindly go through it. We can solve it by base method, taking 330 as the base. This is plus 1, this is plus 1, so you can see this is your 1, and this is 32 into 3, so this is 96, 9 and 1, this square will be 961. Okay, so we will be generalizing this method for a while, and how I will be writing, I'll just show you. Whenever a number be given to you like 24 square, what you do, you take the last digit, you add it to itself, like 24 plus 4, and then you multiply with this first number. So this is multiplied with 2, and the last digit will be the last digit of this number, square of this number. So this last digit will be like 4 square, and if any number will be there, you just carry it up. Now this might look a little bit complicated, but slowly you will get used to this. What is this? Like suppose I am asked to write 24 square, I will do 24 plus 4, which is 28. When 28 is multiplied with 2, it will be your 56, and 56 I will remember, and I know that 4 square is 16, so 56 plus 1, it was 56 bar 16. So what I will do, I will be taking this 1 mentally over here, so it's 5, 7 and 6. So this is our answer. Okay, this is one very quick multiplication trick, which I hope you must have seen my multiplication like lecture, and then it will be easier, but other tricks also we will be discussing later. Okay, so first one, so I know that this 30 square, now coming back to the question, sorry for this digression. So as now we can see that this 30 square is 900, 31 square is your 961, sorry, 961. So what will be your 32 square? Now very quickly you can see that even if you don't have any knowledge, you can see this 32 is 2 to the power 5, this is square, and this is so 2 to the power 10, a very important number in all computer like related paper, bits and bytes, like bits. So this will be around 1024. Okay, so this first number of 4 digit is coming at 32. Okay, and what about 1000? Means 100 square. So 100 square is 10 to the power 5. So till 99 square you will get a 4-digit number only. So very first thing what my understanding says, that the square root of xxyy, let us say this is n, so this n will be in the range of 99 to 32. This is the very first thing what I will understand. Now second thing what I see, let me rub this again. Okay, so till now we wanted to find xxyy, so this was n. I know that this n will be within the values of 32 to 99. Second thing what I see, that these two numbers are same. So this same, so I will start scanning numbers from 1 to 24 whose square last 2 digits are same. And then you will come to see that only 12 square is 144. Means last 2 digits of this number is same. So it means that this particular number has to do something with 12, and it will be nearby the multiple of 50. So in the range of 32 to 99, what are the multiples of 50? So you have multiples of 1 is 50 only. Okay, so this number has to do something with 12. So let us subtract 12. So this is 38. Let us add 12. This is 62. Okay, so are we getting the number? Let us just check. So let us do 38 square. So 38 square, you can very well see it is coming to be 1444, and 62 square is coming to be 3844. Okay, so one thing is fine, that these two numbers are same. But what about these two numbers? Are these numbers same? No. So this is not an option. This is not an option. Do we have any another multiple of 50 in this range? No. What about 100? If we do 100 minus 12, what will we be getting? We will get 88. And if we do 100 plus 12, we will be getting 112. 112 is outside our range. This we know. Whereas this is still in our range. So let us do the square of this. And you can see this is coming as 7744. So now this are same and this is same. So just you can see that this under root of this will be 88. Okay. Now some of you might also feel that like 40 square. This is 1600. So you can very well see that these two numbers are same, but this is not satisfying our condition. So like 40, 30, 40, 50, 60, 70, 80 and 90 are having same trouble, that here YY are not coming to be same. So we rejected these options, and now only out of this is the correct answer. Okay, so you just have to keep an eye that first I fixed the range, second I saw the multiples of 50 and it's plus minus 12. So here was 150. Now 100 is not in this range, but surely 100 minus 12 is in the range. And when we check this 88, so this was our answer. Now, if you have the understanding of this sort, you can very well see that another part of question where it was asked that how many such solutions are possible if this x are not same, means any number, if it is on the form like x, y and z. So under root, how many such solutions are possible? So very well you can see there are multiple solutions. First 1, 2 and 3 and then all these numbers. So total solution will be 40, 50, 60, 70, 80 and 90 and then these three numbers. So it will be 1, 2, 3, 4, 5, 6. So there are 6 plus 3. Total such 9 answers are possible. Okay, I hope this is clear now. So the takeaway, I will be just concluding this particular topic. So this particular topic, if I conclude, so in basic what we saw, we saw that concept of last digit. So last digit, something numbers were missing, which were 2, 3, 7 and 8. Then we saw that last digit is not sufficient, so we went for last two digits. And this last two digits, there was one theorem we saw that any multiple of 50 plus minus any number of x, when you will multiply, the last two digits will be same as the last two digits of this x square. This was the second. And from this we concluded that we need to remember the square of numbers till 24. And once if you remember this, then all subsequent topics will be easier for you. Okay, so with this I am closing my first topic of this basic, and then we will be seeing the general methods in further slides. Till then, Jai Hind, Kaatil Kabootar signing off.